Alright, in this video we're going to talk about finding vertical asymptotes of rational functions. So let's go ahead and get started with this one. We have f of x here, and to find the vertical asymptotes, let's start by finding the domain of f of x. Okay, so to find the domain, we need to find when x squared minus 2x plus 1 equals 0, okay? Because any values of x that satisfy that equation are not allowed in the domain, right? Because you can't have 0 in the bottom of a fraction. So let's go ahead and factor this. Let's think of two numbers. When you multiply them together, you get 1. And then when you add them together, you get negative 2. So that would be negative 1 and negative 1, right? Multiply this together, you get positive 1, and if you add them together, you get negative 2. Okay, now I could set them both equal to 0, but they're the same thing, so let's just go ahead and write x minus 1 equals 0 and solve. So this would then be x equals 1. So basically, x equals 1 is not part of the domain. So the domain is negative infinity to 1, and then 1 to infinity. Okay, so x equals 1 is a vertical asymptote because f of x is not defined when x equals 1. Okay, so now moving on to another example. Same thing, that we basically need to do the same thing. First is find the domain. Okay, so we'll go ahead and start with that. So find the domain. So 3x squared minus 8x plus 4. When this equals 0, the x's which satisfy this equation I've written here will not be part of the domain. Okay, so let's go ahead and factor this. Okay, to factor this, first thing you do is you do 3 times 4, which is 12. And you think of two numbers, when you multiply them together, they give you 12, but then when you add them together, they give you negative 8. Those two numbers would be negative 6 and negative 2. So let's go ahead and write those down. So negative 6x minus 2x plus 4. Okay, so I just broke down this negative 8 into two parts. All right, now let's pull out the common piece for here and pull out the common piece for there. So I have 3x squared minus, oh, that's not right. I can also pull out an x, and I should also pull out an x. So 3x, and so then I'm left with just 1x here minus 2. And then if I pull out, let's see, I can pull out a negative 2 here. So then I'll have x minus 2. Alright, so x minus 2 is common. So I'll have x, or 3x minus 2. Okay, that's coming from here and here. And then that being multiplied by x minus 2. Alright, so let's go ahead and set those both equal to 0. Either of them equals 0, the whole thing equals 0, so let's go ahead and solve that. So add 2 to both sides here, so I'll have 3x, and then divide both sides by 3. All right, and then over here, add 2 to both sides. Okay, so x equals 2/3 and x equals 2. If you were to write your domain, if you were to say domain, you would say, okay, so I'm going from negative infinity all the way till I get to 2/3. And then I go from 2/3 to 2. And then from 2 to infinity, okay? So basically, x cannot equal 2/3 and 2, right? So then what is your vertical asymptote? So your vertical asymptotes are x equals 2/3 and x equals 2. These are your two vertical asymptotes because the function f is undefined at those values of x.